Hello everyone, in this video we will look at how we can automate deployment to AWS using Terraform and GitLab CI CD. And these are all of the things that we are going to cover in this video. First, we will start by setting up our Terraform configuration files. Then we will configure the GitLab CI CD. Then we will get to know how to securely manage AWS credentials. And we will also create and deploy a VPC and EC2 instances automatically. Then we will validate, plan and apply our Terraform configurations using GitLab CI CD. And the prerequisite for this video is going to be you should have AWS account, Terraform install, GitLab account, AWS credentials, you should have your access key and secret key, and you should also have AWS CLI installed. The link for all of this is given in the description. Okay? So let's get started. Now that we know what we are going to cover, let's start with configuring AWS. We have to set up the necessary AWS credentials and permissions to ensure that the Terraform and GitLab CI/CD pipeline can interact with AWS securely. So for that, I already told you that you will be needing access key and a secret key. If you want to know how to get your secret and access key, please check the documentation for this topic provided. The link for it is given in the description. Okay, so let's first make sure that we have AWS and Terraform installed. For this, run the command AWS --version and Terraform --version to check the version of your AWS CLI and Terraform. Okay, and once you have your keys, let's run the command AWS configure and then let's hit enter. This is going to ask you for AWS key, but as you can see here that my key is already provided. But for you, if it is not configured, provide your access key, then hit enter. Provide the secret key, default region name provided as US East 1, and then let's hit enter. Output format, it is going to be JSON. And that's all we need to configure our AWS. And now the next thing we have to do is to set up our Terraform project and its configuration file. So in the terminal, we are going to create a new directory and we are going to create all of the files that we need. These are all of the files that we will be needing. First, we have created a folder named VPC and a web. In VPC module, we are going to have three files, that is main.tf, outputs.tf, variables.tf, and inside the web folder we will have main and variables.tf files. Then we will have the gitignore file, and in the root directory we will also have backend, main, provider and variables.tf file. So these are all of the files that we need to work on with. So let's start with the VPC module. So our first file, that is main.tf, which is present in the VPC module, it is responsible for creating the virtual private cloud or VPC and its associated resources. So in this file, we start by declaring a resource of type AWS VPC. This is an AWS virtual private cloud, and we have named it as my VPC. Inside it, we have the CIDR block that is going to specify the IP address range, and we are bringing the value for this from a variable named VPC CIDR block that we will create in our variables.tf file present in the VPC module. And we then have enabled the DNS support and host names that allow internal name resolution within the VPC. Then we declare the tags section, which is used to label this VPC with the name my VPC, making it easier to identify in the AWS management console. Then we declare a public subnet resource. This is going to define the subnet within our VPC. The VPC ID is going to link it to the VPC we just created, and the CIDR block, it is going to specify the IP range for the subnet, and here too we are bringing the value for this from a variable named public subnet CIDR block that we will create in our variables.tf file. And also we have set the map public IP on launch to true, which is going to ensure that the instances launched in this subnet gets the public IP addresses. And the availability zone, here it is going to specify the specific zone within the region. And in this also we have the text section to help us label this subnet, and we are labeling it as public subnet. Next, we are going to declare the security group resources named public_sg. This is the resource that is going to define the security group. This is going to act as a virtual firewall for instances. Then we have this ingress rule, which is going to allow SSH access from any IP addresses. And the egress rule is going to allow all outbound traffic. Ingress is the traffic that is coming into the security group, and egress is the traffic that is leaving the security group to internet. And all the variables that you see over here are coming from the variables.tf file, which we will create in a matter of moment. So that is all that we have for this main.tf file. So let's save this file, and the errors that you see over here, it is because we don't have variables set up into our variables.tf file. They will just go away when we declare the variables. But for now, let's work with outputs.tf file. In this output.tf file, we are going to define the outputs that the other modules uses. Here we are going to define the output that the web module will use. And the output that is public subnet ID, here it is going to output the ID of our public subnet. This is the output variable that we will use in web module to get the public ID from the VPC. And next we have public security group ID. This is going to output the ID of our security group to be used in the web module. So basically this is done to create resources within the VPC, and that is what we have for outputs.tf file. Let's save this file and open variables.tf file. This variables.tf file will declare all of the variables that we have used in our VPC module. So we will start by declaring the variable for VPC CIDR block. Its default value is set to 10.0.0.0/16. This is going to represent a network range in the private IP address space. Next, we have another variable that is public subnet CIDR block. This variable, it is going to represent the CIDR block for our public subnet within the VPC. Then we have next variable, which is availability zone. This is going to represent the availability zone where our public subnet will be created. The default value here we have set it to US East 1A, which is one of the availability zone in the AWS US East. You can look more about the availability zone into AWS website, okay? Then we have another variable that is security group ingress CIDR. This is going to represent the CIDR block for incoming traffic to our security group. Default value is set, which is going to allow traffic from any IP address. And this is the last variable that we will have for this file, which is going to be security group egress CIDR. We have set its default value, and this is going to allow traffic to any IP addresses. And you can see that the error from the main.tf file has vanished because we have declared our variables in variables.tf file. So let's save this file, and here we are done with our VPC module. Next, we will create the EC2 instance. So for that, we have to work with this web module. So let's open this main.tf file. In this file, we will have an AWS instance as a resource that will define an EC2 instance with the name server. Okay, then we have the AMI, which specifies the Ubuntu image ID for this instance, and the instance type specify the type of the instance, and here we are going with the free tier. The subnet ID and the security groups are passed as variables to associate the instance with the correct subnet and security group. Then we have the tag section that is going to label the instance as my server, and that is what we will have for main.tf file. Here the AMI, you can use any AMI that you want. To get this AMI, you have to go to your account and look for the AMI for your specific account, but you can use any of the public AMIs also that are available. Okay, now let's define the variables in variables.tf file present into the web directory. Here we are going to declare all of the variables that we have used into main.tf file. So we first declare the subnet ID. This is the first variable that is going to store the ID for the subnet for the EC2 instance. And then we have the second variable, which is security group ID, that is going to store the ID of the security group for the EC2 instance. And here we are done with creating VPC module and web module. And now we will join everything together by calling the VPC and web modules into the main.tf file, which is present into the root directory. Here, first off, we declare the module VPC. This is going to call the VPC module that we just created to create the VPC, subnet, and a security group. Next, we will create another module which is going to be named EC2, that is going to call the web module to create the EC2 instance within the VPC. The VPC module outputs are here passed as inputs to the web module to ensure that the EC2 instance is created in the correct subnet and with the correct security group. And that is what we have for this main.tf file. So let's save this file, and now we will work with provider.tf file. In the provider, there is nothing much to do. Here we are just going to specify the AWS provider configuration. Here we have the provider AWS. This is going to configure the AWS provider and set the region for it to US East 1. Save this file, and then let's head to variables.tf file. So in the variables.tf file, we will just have this one variable that we have used in provider.tf file, that is region. Right? We have set its type to string and default to US East 1. And now the last thing that we have to do is to add a .getignore file. We are going to add this getignore file because we don't want our local Terraform directories like its state file to be pushed with our code to GitLab. So for that, what we will be doing is we will be bringing this .getignore file from the browser. So in the browser, search for Terraform getignore, and the first link that you see over here of GitHub is the file that we will need. What we will do over here is copy the raw file and then head to VS Code and paste the code that we have copied. Yeah, just like this. And we are done. Now that we are done with the Terraform configuration file, we are going to test our Terraform code, validate it before pushing it to the GitLab. Open the terminal and run the command AWS configure to check that you have configured your AWS correctly. Alright, then we are going to run the command terraform init. This is going to initialize the modules that we just created like VPC and web, and you will then have the .terraform folder generated. You will see it has initialized EC2 in web and VPC in VPC, and there we have this .terraform folder over here, which is going to contain all of the modules that we have created. And then over here we have this Terraform has been successfully initialized. You should get this message. Okay, and now we will validate our code. For that we have the command terraform validate, and then let's hit enter, and here we should have this success message which says that the configuration is valid. Perfect. Now let's check what are the changes which are required by our configuration. There should be 4 changes that should have been done. VPC, subnet, security group, and EC2 instance should be created. And then let's run the command terraform plan, and then we have this 4 to add, 0 to destroy, 0 to change. And now to create and update our infrastructure depending on the configuration file, we have to run the command terraform apply. So let's do this. I think it has generated this terraform.tf state. So one thing we forgot to put in our command is -auto -approve. I'll show you what I'm saying. Here you have to enter the value, yes, but we don't want to manually enter this. So let me first just stop this and let's run the command again. And this time our command is going to be this terraform apply -auto -approve. And then let's hit enter. And this time we don't have to manually put yes. This is going to take couple of moments. So till that time, let's go to AWS website. You have to go into this EC2 and then head over to this instance is running, and you should have your instance, that is my server, and this has started initializing and its instance status running. Head back to the VS Code, and now we are going to destroy everything by running the command terraform destroy --auto -approve. So like these are all of the files that is going to define and automate the deployment of our infrastructure on AWS. Because we don't want this terraform.tf state file to be on our local machine. No, that is not a good practice. Okay, so for this we will be creating S3 bucket and a Dynamo table. And now to create the S3 bucket and the Dynamo table, what you can do is you can either go to the AWS site and create the bucket and Dynamo table manually, or you can do it with commands. So I'm going with commands. So here we have the command that is this. The table name is my Terraform CI/CD DB table, and we have the primary key that is lock ID. It is set to string. Okay, and then let's hit enter. You can do this only if you have AWS configured. And now we have to create the S3 bucket. So for that we also have a command that is going to be this AWS S3 API or whatever, and our bucket name here, it is going to be my Terraform CI/CD bucket, and the region is set to US East 1, and then let's hit enter, and this is going to create the S3 bucket in our AWS website. And then we also have to ensure the versioning of our bucket for better state management. So for that we have this command over here, and then let's hit enter. To get all of these commands, you can check out the documentation for this video tutorial. The link for it is given in the description. And that is all that we need to create the S3 bucket and Dynamo table. And once that is done, head over to the AWS website, click on DynamoDB, go to tables section, and here you will have this table with the partition key or primary key lock ID. So this is the table we just created, and go back and then go to S3, and you should have your bucket created over here. And now the next thing that we have to do is to set up the S3 state backend. This is going to be done into this backend.tf file. This is an important file for our Terraform configuration, because this file, it is going to set up remote state management using our S3 bucket and the DynamoDB table. This is going to ensure that your state files are securely stored. So this file is going to configure the Terraform to use the remote backend for storing the state file. This is the state file over here. So in this file, we are going to specify that we are going to use an S3 backend for storing the Terraform state file, and the bucket that you see over here is the name of the S3 bucket where our Terraform state files will be stored. In this case, we have my Terraform CI/CD bucket, and then we have the key, the path within the S3 bucket where the state files will be stored. Here we have set it to state. Then we have the region, the AWS region where our S3 bucket is going to be located, and we have set it to US East 1. And at last we are going to have Dynamo table, and the name of the Dynamo table, that is my Terraform CI/CD DB table. And that is what we have for this backend.tf file. So let's save this file also, and then run the command terraform init, and you can see over here this is initializing the backend, and it has successfully configured the backend S3. And here we have the message, Terraform has been successfully initialized. And that is all. Now we just need to automate all of this, and for it we have to start off by pushing our code to GitLab. And now we need to create a GitLab repository to host our Terraform configuration file. So for that, head over to GitLab website, make an account, and afterwards you will see this kind of a dashboard, and over here you have to click new project and then click on create blank project. Here we are going to name our project. I'm going with the name Terraform CI/CD AWS, and then let's scroll, and then let's hit create project. After, you will scroll down. Here you will have this git remote add origin command. So grab this and then head over to VS Code. And now we need to initialize a new Git repository in our project directory. So for that we have the command git init, and you should have the message initialized empty Git repository. Okay, and then here you have to then paste the command that we copied, git remote add origin, and then let's hit enter. And now we don't want our code to be pushed to our main branch. Instead, what we will do is we will create a new branch and name it as dev environment, and then let's hit enter, and you will get this message that it has switched to new branch, that is dev env. Okay, and now we have to add all of our files to the repository. So for that we have the command git add, and then we also have to commit them. So for that we have the command git commit -m initial commit, and then let's hit enter, and these are all of the files that it is going to push to our repository. So to push the file to GitLab we have command git push -u origin, and then the branch name, in our case it is going to be dev environment, and this is done. So when you head back to the GitLab's repository, refresh this page, and you should have this create merge request button over here. For some of you it might ask you to provide the username and password for your GitLab if it is not configured with the VS Code. So here it will give you like a block to put your username and password, so put them, and then it is going to push your files to the GitLab. But for me it was already configured. And now here we have this create merge request, right? And here you will have this branch button. You can see that we have main branch as a default and dev-env as another branch, and now we are going to create the merge request to push the code from this branch to the main branch. So for that let's click on create merge request, and here it is going to ask you for the title. So let's have the title anything that you want. Let's say initial commit to main, and then you can provide the description. It is a good practice, but as it is just me working on this project, I'm not going to provide description. But when working with the large projects, you should provide the description of the changes that you have done. And then let's hit create merge request, and then you will have this page. When you scroll you will have this merge button, so click on merge, and it is going to merge our dev-env branch to main branch. Okay, and you can see over here that this was merged just now, and there you will have all of the code present from the dev-env branch to our main branch. Now let's set up our GitLab CI/CD pipeline, which is going to automate the deployment of our infrastructure to AWS. This is the crucial part of this video. So let's get started with CI/CD. For that we need to create a new file that is going to be GitLab CI.yaml file. So for it, click on this plus button over here, then click on new file, and then provide the name for your file that is going to be gitlab-ci.yaml. Don't forget the dot at the front. Okay, and here we are going to write the code for our pipeline. So this is all of the code that we need for this file. You don't need to worry what's going on here. I will explain every stage and task to you. So here basically we start by specifying the Docker image to use our pipeline. This image is going to contain all the necessary tools and dependency to run the Terraform commands. Image over here, it is going to specify the Docker image for the pipeline, and here we are using the image that includes Terraform and other tools. And the entry point here sets the entry point for the Docker container. By using /user bin and then env, we are ensuring that the container starts with the correct environment variable and the path. Next, we define environment variables that our pipeline will use. These include AWS credentials, access key and the secret key, and also the default region, which is set to US East 1. So these variables are needed to authenticate with AWS. We are passing them with the GitLab CI/CD variables, and we will set this variable in just a matter of moments. Okay, next we have the before script section that is going to run before any of the job in the pipeline. It is going to prepare the environment. Terraform version is going to print the Terraform version to verify that the Terraform is correctly installed. Then we have another command, that is Terraform init. It is going to initialize the Terraform configuration. This command is going to download the necessary provider plugins and set up our backend configuration. Then over here we have 4 stages. Our pipeline is divided into 4 stages. Each stage is going to represent a phase of the deployment process. We have 4 stages named validate, plan, apply and destroy. The validate stage that you see over here, it is going to check the syntax and configuration of our Terraform files. Stage is going to specify that the jobs belong to the validate stage, and the script, which is Terraform validate, it is a command to ensure that the Terraform configuration is proper, is valid. Alright, and then next we have another stage, that is plan. Here we are going to generate an execution plan and save it as artifact. The stage over here specifies the job it belongs to. Like the plan stage, the dependency that you see, it is going to ensure that this job runs after the validate stage is done. And script here is going to run the Terraform plan -out equal to plan file. This is a command to create an execution plan and save it to plan file. And the artifacts over here defines the files or directories to be passed to subsequent stages. Here we are saving the plan file as an artifact. And then we have this apply stage that is going to apply the Terraform plan to create or update infrastructure. This stage we have set it to manual, allowing us to review the plan before applying its stage, dependency, script and when. So states specify the jobs it belongs to. It belongs to apply stage. Dependency ensures that this job runs after the plan stage. And then we have the script that is going to run the command terraform apply -input equal to false and then plan file to apply the saved plan file. And then we have the when, which is going to set this job to manual, meaning it will only run when it is manually triggered. We have to do this, okay? And at last we have the destroy stage that is going to destroy all the Terraform managed infrastructure. This stage we have also set it to manual. So basically this is our CI/CD pipeline, which is going to help us validate, plan, apply and destroy our infrastructure. And now that we are done with creating this file, let's commit the changes. Let's say edit this file, and then let's scroll and let's go with the main branch, and then let's hit commit changes. But before committing the changes, let's do one thing. Let's configure our GitLab CI/CD variables, because we have created the variables over here, right? So let's open GitLab in another window. This is the project that we are working on. Go into this settings, and then over here we will have this CI/CD. Open that. And there we have this variable section. Click on the expand that you will have over here, and this is where we have to add the key value pairs. Let's click on add variables, and let's provide the key that is going to be my AWS access key. Go over here, provide the key, and then we will have to provide our value. So here provide the value and click on add variable. Yes, just like this, and there you will have this my AWS access key. Now we need the secret key, so let's grab this my AWS secret key and then paste it over here in the key section, and then here provide the value for your secret key and then click on add variable. So yes, and there I have my secret key there. Let's head back to this step over here and then hit commit changes, and it should start our CI/CD pipeline. And here we have this message, this GitLab CI configuration is valid, and this is where it has started the pipeline. So let's go over here, and you see here we have 4 jobs: validate, plan, apply, destroy. You can go inside this, and this you will see that it has succeeded the job. Let's go back, and this plan should also pass, and there we have this job succeeded message for our plan stage also. Get back over here, and here we will have this passed tag, and then we have this 2 stages, apply and destroy, set to manual. So what we will do is we will run it ourselves. Let's go over here, click on this apply button, and there we have this message over here that yes, job succeeded for this also. Terraform has been initialized successfully, and the last job is to destroy. Let's refresh this, and you should get the tick over here also. So yeah, now let's run the command destroy. So like it has started destroying, and I think it is also going to take a couple of minutes, so let's wait. And here the job has succeeded, destroy complete resources, 4 resources are destroyed. Okay, so that means our CI/CD pipeline and Terraform configurations are working perfectly. And that is it. We have successfully set up our GitHub CI/CD pipeline to automate the deployment of our infrastructure to AWS using Terraform. And that's all for this video. I hope you enjoyed it and found it useful. If you did, then please do not forget to like and subscribe. Also, if you have any doubts, please drop them into the comments section. I will be happy to help. You can find the link for its GitHub repository and this lesson's documentation in the description. And I'll see you in the next one. Till then, bye bye and take care.